at should be a revision from Year 9 Maths, and it relates to the index laws. So I'm not going to spend much time on this because it is revision from last year, but it is an important skill for us to have. So for some, you might need to spend a little more time just going over some of the examples and working through these questions to make sure that you have those skills that we learnt last year. So what I would like you to do, you can pause the video here and you can copy these index laws into your exercise books. I'm just going to talk through each of them. So in each of the scenarios, you'll notice, or in the first two, you'll notice that we have the same base. So when the bases are the same and I'm multiplying two indices, so if I have a to the power of m times a to the power of n, essentially the base stays the same and I can add the indices. So we will get a to the power of m plus n. Or if I have, again, the same base and there's a division, then essentially what happens is I'm subtracting the indices. Another way that this could be written rather than using a division sign, you could see a fraction symbol used. If I have a to the power of m all raised to the power of n, then we multiply the indices. If I have a times b, so now you can see that I have two different bases, and each of those are raised to the power of m, then this can be written as a to the power of m times b to the power of m. And similarly for a division, if I have a over b all raised to the power of m, it can be written as a to the power of m over b to the power of m. So just please copy these into your exercise books, and then we're going to work through some examples. So these are from chapter 2B of the Oxford textbook, and I'm just going to go through a few examples, and then once I've gone through these examples, you'll have the remainder of the lesson to work through some questions that I've set on Sector, and you can access me via Teams if you need help with some of the questions. So if I have n to the power of 15 divided by n, you'll notice that this n doesn't have an indice. However, since it's n, it must be n to the power of 1. So you can just imagine that there's an imaginary 1 here. N to the power of 15 divided by n to the power of 1. We subtract the indices, so I'm going to have n to the power of 14. Now you can see that we have a multiplication, and we have two bases. So essentially it's h to the power of 1 times h to the power of 6. Sorry, that's a little bit small. So essentially, again, we're just adding the indices. So it's going to be h to the power of 7. Here I have x to the power of 11 divided by x to the power of 5. And you'll see throughout the topic, we'll generally use a fraction symbol rather than a division symbol. But the rule is the same. When the two bases are the same, then we're just going to subtract the indices. So it's going to be x to the power of 11 take 5, which is x to the power of 6. Now we have three terms, and each of them are being multiplied, so we're adding each of the indices. A to the power of 2 times a to the power of 1 times a to the power of 7. So this is going to be 7 plus 2 plus 1 is 10, which is a to the power of 10. Next up, in example 2b1, I have been asked to write the following with positive indices. So if I look at this, I have m to the power of negative 7 times n to the power of 2. So since this is a negative indice and I want to write it as a positive indices, there's a bit of a trick we can use. Since the n to the power of 2 is already positive, I'm not going to do anything to that. That's going to stay where it is. However, I can actually write this as, if I flip it to the bottom of the fraction, over m to the power of 7. So you can see that I've written this now as a division, and now it's a positive indice. If We look at this next example, 12 times a to the power of 3 times b to the power of -5. So that is going to have to be converted to a +5. So again, essentially what's going to happen is it's going to come to the bottom of the fraction, and that will become a +5. And down here you can see I've got a -6, so that's going to have to come up to the top of the fraction, which is going to reverse that negative symbol. So the 12 a to the power of 3 can stay as is. I want this c to the power of -6, I want it to be +6, so I can write it at the top of the fraction, which will be c to the power of 6. And at the bottom, I've still got my 4, and then I've got b, and I'm going to raise it to the power of +5 since it's come to the bottom of the fraction. Now this can be simplified further because I know that 12 divided by 4 is 3. So it's going to be 3a to the power of 3, c to the power of 6 over. The 4 is no longer going to be there because I did 12 divided by 4 to get that 3, which is just b to the power of 5. Okay, and the final example that we'll look at, we have to use the index laws to simplify the following. So a to the power of 4 times a to the power of 3 raised to the power of 2 over a to the power of 7. So first let's simplify this indice here. So the a to the power of 4 is going to stay as is, times a to the power of 3 raised to the power of 2, we multiply those. Is going to be a to the power of 6 over a to the power of 7, and we can start a new line for each part of our working. So now I have a to the power of 4 times a to the power of 6. They have the same bases, therefore I can add the indices. A to the power of 10 over a to the power of 7. And finally, I have a to the power of 10 over a to the power of 7, so I can subtract the indices, and I'm going to be left with a to the power of 3. Okay, so I've set a range of questions on sector which you're going to work through. Again, this is revision from last year, so see how you go with them, and if there's particular questions that you struggle with, let me know and I'm more than happy to give you a hand with them. Just one last thing to note before I leave you to it. From our key ideas from this chapter, just something that you would have learnt last year, that anything raised to the power of 0 is always equal to 1. So in some questions that may be useful for you. You can see that we use this property in some of those examples that I went through. If I have a to the power of -1, I can write it as a positive indice by writing 1 over a. And again, the positive 1 is there, but we don't write the positive 1. If I have a to the power of -m, if I want to write it with positive indices, I can write it as 1 over a to the power of m. And here I have 1 over a to the power of -m, so that could be written as a positive indice as a to the power of m. Okay, so we'll leave the video there for now. So good luck with those questions, and please do let me know if you have any questions.